All right, welcome. My name is John Morello. I am the CTO of Twistlock. Just a short amount of background on us for you guys, if you're not familiar already. We were the kind of industry's first cyber platform for cloud-native apps, so obviously containers are a big part of that, but also serverless functions, cloud-native VMs that are operated in an autonomous and really stateless manner. And really, we've been involved in this industry or in this space for the entirety of our company since 2015. And one of the things that we found over that time is that the challenges that face customers, or that customers face, I guess, oftentimes are broader than what we talk about at conferences like KubeCon. Like here you guys are able to go, or I guess we're all able to go to, really interesting sessions about the very next things that are coming in technology, like very innovative stuff that, may not be actually production ready, but it's going to be really cool and it's going to kind of set the direction of things for the next 5 years. That's not what this talk is about, actually. This talk is about something that is, I think, much more real and practical when you think about all this great stuff that we as an industry and as a community have created around orchestration and containers and this whole new way of computing and developing and delivering applications still has to deal with the reality in most industries that doesn't mean that means that basically you're not going to be able to upgrade everything to the very latest versions the next day. If you look across like the Fortune 1000 sort of organizations in the world, most of those organizations are not going to be able to deploy all of their workloads in Kubernetes ever, right? They've got a huge amount of legacy infrastructure that's out there, a huge amount of legacy applications that are out there, very real compliance and security requirements that you can argue about whether or not they make sense or not, but the reality is they're required from a governmental standpoint. And so how can we help those kinds of organizations, which is really the bulk of humanity, I guess, or certainly of like the enterprise space, how can we help those organizations realize the value of these capabilities in that workload base that they already have while they're adapting and adopting these technologies for the newer stuff that they have in a more cloud native kind of natural way by default. And what we're going to do during this session is talk about a particular customer we have that has gone through this journey of basically taking a legacy workload that was really mission critical to them, that they've had in their organization for well over a dozen years at this point, that obviously didn't start out as a containerized app, didn't even start out virtualized, and to talk about the values that they got, the benefits they got of migrating that to containers as a way to understand how this can be helpful to organizations really of all sizes and all industries that are out there that face similar challenges. One of the things that I often tell customers, and I think you guys have probably observed in your own personal work lives as well, is complexity is never destroyed. It's just moved around, right? If you go out there to any Fortune 1000 organization, I can assure you that they have Windows 2000 machines that are still there. They have applications that they depend on every day that are like Java 1.4. And that stuff doesn't just disappear overnight. A lot of those organizations have mainframes and still, probably will have mainframes for the foreseeable future. But that doesn't mean that they can't get advantages from taking those applications and packaging them up in a way that leverages the capabilities in this cloud native stack to be able to get additional benefits from a security standpoint, in addition to all the agility and developer benefits that drive people to make these decisions in the first place. So I want to first start talking about like what is this notion of lift and shift? Like what are the things that customers are going to go through when they think about a lift and shift of an application with containers? And then what does that customer example really look like? We're not going to talk about all the mechanics of like containerizing an application. Everybody knows all that, and that's not particularly interesting. But what we're going to really focus on is what are the security advantages of that? Like what do customers get through this process? And then we'll save some time at the end for some Q&A. I think one of the things that could be really interesting, hopefully, for you folks is we've done this with a lot of customers. Like I said, we've been around for several years now. We have hundreds of customers all around the world in lots of different industries, and we've seen a lot of people take advantage of this journey. And so if you have questions about how that applies to your own organizations or some best practices and pitfalls, those are the kind of things that I'd be happy to share, obviously anonymized information about, but information about what others have seen as they're going along this journey. So if you think about what the definition is here, I think it's always important to be clear about what we're talking about. When I talk about lift and shift in the context of this case study that we're going to spend all the time on, it's about how do you take an app that was never really developed with cloud native in mind, because it might predate cloud native by a decade. How do you take that and deliver that into a different way of managing and developing that application? How do you containerize it and how do you run it after you've done so? And then more importantly, it's like, what are the benefits that you see from it? Why would you want to do that specifically from a security standpoint, in addition to all like the DevOps and agility benefits that you get from containerization? And that's really what we're going to be looking at today, is the specific values that you get from security by adding this capability around your application for being able to easily deploy it, to be able to run it in a more stateless way at least, and to have the kind of intelligence that you can get simply by containerizing an application and utilizing that outward bound sort of declarative and minimalistic approach that containers and cloud native enables you to have. How can you leverage that from a security standpoint to improve your overall security for the same application? So the flow that people really usually go through with this or the rationale, I should say, that people go through for why they do this lift and shift in the first place, usually is around three major reasons. The first two I'll just talk about to set the context, and the third one is the one that we're really going to focus on from a security standpoint. But obviously, if you're a CTO or even just an engineer at an organization that may have a large legacy IT investment, one of the things that will probably drive you to thinking about cloud native and migrating some of these initial applications is to get experience with operating that platform and to do it in a meaningful way, right? Like, everybody can set up kind of a hello world application or a website that doesn't serve up anything and say like, look, I've used containers or Kubernetes, but as I think everybody would recognize, that doesn't really give you the kind of operational experience that actually doing it with something that matters delivers, right? Like, if you're going to do it with an application that people use and depend upon, you're going to really care a lot more about it. You're going to investigate all the boundaries of it and understand how to use it in your organization. And that's the thing I think that drives a lot of that initial exploration. Additionally, the capability that you get simply by putting something in a container, even if you're not running it in a fully like orchestrated manner, even if the application is not truly stateless at this point in time, even if like the practices that you use from an operational standpoint don't really reflect all the great things that you can do with service meshes and all the capabilities that are available today, just taking that old app and putting it in a container can deliver some really significant benefits to you from an operational standpoint, right? Test and deployment becomes instantly much easier. We have a large financial services customer, one of the largest credit card companies in the world, that is doing this exact process now with literally hundreds of legacy applications they have, with the full realization that this migration for those legacy apps is not going to magically transform them into something that's a cloud native application. It's not going to magically make those apps like infinitely scalable and so forth. But what it will do is to change the paradigm that they currently have, which is when they have a new build of the app, there's some poor guy that gets like a 45-page Word document with screenshots, and when they want to deploy that app, there's actually a person that sits through there and clicks buttons and types commands, and at the end of it, they still have to fight with version compatibility issues and all the other crap that people deal with legacy sort of applications. When you simply containerize that app, there's a lot of benefits to be gained from that, and that agility aspect of it is one of the big drivers for it. Additionally, that notion of improving automation and efficiency also encompasses the whole kind of DevOps process, right? Because once you have it in containers, obviously it's easier to integrate with the DevOps flows that you're using. You can have more of a pipeline-based approach to building your application. Even if it's a monolith, just again, getting in a container makes it a lot simpler to have a consistent thing to use in development and test and then ultimately in production. But the thing that we're really going to focus on today is the improvements that you get from a security standpoint, what those actually are, how they're realized, and really what are the other options that you have once you make this migration to further improve your security in this cloud-native space. So let's talk about a specific customer example. I'm going to give you a background for what that customer looks like and the kind of use cases that they have, so you can have a clearer picture of the kinds of challenges that they're faced with. So this particular customer is an environmental, consulting organization, you might say. They're a science-based organization that does a lot of work with waterworks projects, things like large river diversions, sediment diversion projects, and so forth. And this organization does a lot of work also with many different governmental organizations, not just in the United States with the U.S. Army Corps of Engineers, but also here in Europe. Obviously, you guys might be aware of all the work that has happened in the Netherlands around water management and so forth, and there's a lot of expertise in Northern Europe that this organization helps leverage and apply for U.S. sorts of situations as well. So this application that they have is something that they've used for many years now. I think that as best I think anybody there knows, it was developed somewhere around like 2005 or so. It was originally developed on Java like 1.2 or something, or 1.3 or something of that nature. And this is an application that they use for a variety of different parts of their workflow. It's kind of this ugly thing that, as you guys have seen probably with lots of other applications, started out doing one particular thing and then got additional things added to it over time, to the point now where it's almost like this like office suite beast of an application. Initially, it was designed to basically be a tool for modeling things like storm surge and the effects of a river diversion or a levee that would be put in one place. How does that impact water usage in other areas of the coast? Over time, they also added capabilities to it to figure out, well, given a certain project and budgets for that project, how would different kinds of investments of that budget and different technologies affect the outcomes from a science standpoint? And so the applications become fairly complex. The use cases they have for it are also complex because of the specific end users that consume the application. So it's not just an app where you have a set of internal people that are all in the same managed directory and they log onto it from a browser or computer that you have some control over the standards for. The reality for this particular application is it's used by people all around the world. You can't control the device they have. You can't control the browser version that they have. You also don't have the ability to really enforce any kind of modern ways of doing authentication. All of the accounts that are used for authentication of this app exist locally, and that really limits your ability to protect that application from kind of remote attack. By definition, it's something that's got to be exposed to the internet as a whole, because you don't know if you're going to be working with somebody who's, in the United States or in Denmark or in Cambodia, for that matter. And so it's really open to the entire internet. Obviously, as we talked about earlier, it uses a lot of really legacy components there, so there's a high risk of vulnerabilities being found in those components and being difficult to remediate. And that application is also something that has a lot of data that is under various regulatory regimes. Because they do a lot of work with the U.S. government, they're required to have FISMA compliance capabilities and to be able to attest to their compliance with FISMA. Because they do a lot of work with people in Europe, and they store obviously things like contact information for those individuals. Now GDPR is a concern that they have. So those aspects of their requirements are not things that they directly control, but like most other enterprises out there, they nonetheless have to live with those applications, and they have to understand how does that impact their ability to secure them, and what are the trade-offs that they have to make to be able to do so. Because that application and because the users are also coming, again, from across the internet and from basically any kind of device, it also limits the kind of pre-check abilities you can have. You can't necessarily do a proxy-based solution where people are going to first authenticate through some kind of SAML provider like G Suite or something before they come into it, and you have at least sort of a filter of the authentication that's traffic that's coming in. Instead, again, the model is everything happens directly with the application. So this is one of those cases which you often see in a lot of legacy environments in which all of the advantages are basically with the attackers, right? This organization, the people that are responsible for defending this application and the data that it has, are really at a significant disadvantage. They're stuck with using old tools. They don't really have the ability to control where people are able to come from. They don't have the ability to really use modern authentication suites. They have a huge amount of regulatory burden that they have to deal with and to prove compliance around. And those are all things that are really hard to do with traditional applications that aren't in a container basis, because it makes it harder for them to be able to show consistency of that application as it goes from development to test to production. Now, like most organizations that are in this same space, this isn't an app that they're iterating on and shipping a new build of every day, right? Enterprises are very thrilled usually if they can go to quarterly release cycles. This is a huge step forward for most Fortune 1000 sort of organizations. And the same thing with these guys. Their goal here is not to be fully agile and to be able to ship new code in production every day before lunch. Their goal is to really be able to still have almost a waterfall approach with shorter iterations. Obviously, talking about something that might happen every few months versus, once every year or even more than a year. But how do you do that in a way where you can have greater consistency between development and test and production? And particularly from a security standpoint, how can you show the organizations that you have to prove compliance with, how can you show that you're doing all the things that you said that you would do to actually protect that application? Not just the vulnerability management, but also the configuration of the application itself. This application has also had an interesting kind of ride in terms of where it's gone and where it's physically existed during its life cycle. It initially started off as a bare metal server that ran in their own data center. Eventually that was virtualized, also in their own data center. And about a year and a half ago, I think, they moved from their own data center into Azure. So right now, this is just simply a very basic sort of configuration. It's not running on Azure Kubernetes service. It's simply just a standalone host, a standalone Azure instance that's running this workload as a containerized workload. And that may be sort of shocking or eye-rolly worthy. But the reality is for, I think, a lot of enterprise organizations, there will be a lot of workloads like that for the foreseeable future because you can't take this application that you wrote that long ago and without significant amount of re-architecture and redevelopment, kind of instantly turn it into something that's fully cloud native, right? But again, you can get a lot of benefits, like these security benefits we're going to get into in a moment, a lot of benefits from simply packaging that up and utilizing containers as a more effective way to package the application and to ensure security of that application. So as I mentioned, they had a few major challenges that really drove them to think about containers as a solution for the problem set that they were faced with. One of the first challenges they had, and what we talked about a moment ago, was maintaining that consistency across the different environments that they have, dev, test, and production. And the reason I wanted to talk about this in more detail is one of the big challenges that they had was the problem that they're faced with when they have one team that's an outsourced team that does the development of the application and a different team, which is an in-house team, that actually does the operations, which is a pretty common model, right? Or maybe both teams are even outsourced, and they may be from different companies that you're paying to do that work. The big challenge they had, and something that was a constant source of frustration for them, was how do I ensure that what we built in development is the same thing that we tested and is the same thing that we're running in production, right? Kind of a classic use case that containers really do a good job of helping you solve. But the biggest challenge from a security standpoint that they faced with that was that what the operations team thought that they had from an operational kind of design and configuration standpoint was wholly divorced from what the development team used to actually build the application. And again, you've probably seen this in your own personal work lives as well, in which you've got a certain configuration, development or test, you build your application, everything works beautifully, then you hand it off to somebody else and it's broken or it crashed or whatever the feedback is that they provide. And the reason for that is you end up with different configurations along the way. And so over time, what really ended up happening for them is, again, a classic kind of enterprise challenge here is that everything just sort of settled down to the lowest common denominator from a security standpoint. If the application worked in development with a particular configuration for the JRE, well, they would just put that same configuration in production without really thinking through the security ramifications of it. If the way that they authenticated users worked in production but not in development, they would just kind of lower the security requirements in development. And this is something that you often see, this notion, I would say not really of security rot, which I think of as more like configurations that go bad over time, but of security compromise, like the fact that you're just going to continuously accept the worst possible solution as long as it makes the application actually run. And that's a hard thing to combat if you don't have a declarative way to transfer that application through the different phases of its life cycle, because you're basically depending on people to have that consistency in what they build and what they operate and deploy over time versus allowing software to do that for you. And software obviously is much more efficient at doing so. DR was another big issue. You can kind of consider DR, I think, always at least to be tangentially related to security. If you think about the classic CI triad, that availability is obviously impacted a lot by DR. And one of the real issues they had with that was the fact that when somebody needed to recover that environment, it was like a multi-day process in a lot of cases, because they didn't always have a crash consistent sort of backup that they could restore with confidence, because as is most of the time, like, you end up making compromises. Some things, like, it worked most of the time and nobody spent the time to really investigate why it didn't always work. And so that was a real challenge, especially in situations where they would have to rebuild the application and restore the data, because again, just rebuilding the application itself was a very difficult and manual process. And we talked about this is great. We talked about this notion as well of the fact that there was continuous security updates over time for the app. The problem that they were faced with, though, is because they didn't want to deal with updating the application when it was in a working state, they basically ignored security updates for years in a lot of cases. They had Java vulnerabilities that would be critical in nature that they just never addressed because everybody was afraid of breaking the app, right? I'm sure none of you guys have ever seen something like that happen in your own organizations, right? Everybody deploys every update as soon as it comes out, right? Of course. It's late in the day. It's supposed to be funny. Maybe it doesn't translate to out of the U.S. So that's a real issue that they were faced with too. Is like, how can I actually utilize some technology, in this case containers, to make it easier and more reliable, basically safer for me to stay up to date, as they knew that they really should be. So we talked about the fact that they were packaged in containers. There's really nothing particularly special about that. But now we're going to talk about the value that they get from a security standpoint through this journey. So there's really three main areas of advantage that they get by putting this application in containers from a security standpoint. Vulnerability management, compliance, and threat protection. We're going to drill down into each of those in a moment. But before we do so, I want to talk about what are the characteristics of containers that really enable them to have a better security posture. Like, from just sort of an academic standpoint, what is it about the nature of containers that enables you to have security more effectively applied to legacy applications, or to any application for that matter? The first area is the characteristics of being minimal, right? A container is a minimal kind of set of code, a set of bits, relative to a virtual hard drive, right? Like, if I have a VMDK, as these guys did of their application, that VMDK includes a lot of stuff, right? It's a full OS, it's drivers and binaries for things that have nothing to do with the application. It's the application, probably even the data for the application, all intermingled in this giant, multi-tens of gigabytes thing. And practically, from a security standpoint, like for us at Twistlock or any other security vendor, the more stuff that you have to deal with when you assess an artifact, an image, or a VMDK, the more difficult it is, I think, to do so accurately, right? There's a lot more chances for there to be corner cases. There's just a lot more stuff involved with it, and it takes longer, right? It's a lot longer to go and figure out all the files that exist inside of a virtual hard drive versus doing that inside of a typical container. So from a practical implementation standpoint, it's really hard to do that effectively if you're talking about really large amounts of data. And so the minimalistic aspect of containers really enable you to do that more practically than you've been able to do in the past. Containers are also really declarative, which is a key thing for enabling software-defined security and software-enabled security, as we do here, which is the fact that a container is built from an image are built from layers are described in a Docker file, means it's possible for software like ourselves or even others to be able to go through and understand in an accurate, comprehensive way all of the stuff that's inside of that image and all of the things that it should normally do at runtime. A lot of that you can learn through just pure static analysis, like you can understand all the packages and components that are in there, some static aspects of their configuration, their versioning, and so forth. You can use that to identify vulnerabilities, to use that to identify compliance defects, like do they have a private key for their database connection string embedded in the image. Those are all things that you can see very easily because there's a consistent, understandable format for what that image looks like. And that enables, again, a lot of security automation that historically has not really been very practical to do, at least not at scale. And then finally is the predictable nature of containers. And this is really the thing that I think enables the most interesting aspect of security around active threat protection for an application that's been containerized. One of the challenges that these guys had, and that, again, you'll see with basically any large organization for the legacy apps that they have, is oftentimes, no one at that organization really understands how the application is supposed to work. And if you don't understand exactly how it's supposed to work, you're almost never going to be able to effectively secure it, right? You might understand on the surface it has a particular version of Java and it listens on port 80, but do you really know like all the process activity that normally occurs in that? Do you know the way that like the front end talks to the data tier or talks to the cache layer? Most organizations don't have that depth of knowledge about the entire portfolio of their apps, maybe not even about most of their apps, frankly. And so what you're able to do with containers, because they're predictable in nature, is you can model what is normal activity. You can learn the fact that this container normally is going to run HTTPD with a particular checksum of that binary. It's normally going to listen on port 80. It's normally going to resolve names in a particular DNS namespace. It's normally going to write files to this path. And so instead of you having to create a whole bunch of manual security rules in an IDS, in a firewall, in an anti-malware suite, to say like what is all the things that could possibly be bad and try to eliminate all those, you can now move to a model in which you're only going to allow those things that are known to be good, to move to an explicit allow list approach to security, because you can leverage that automation that we talked about earlier and the fact that containers are predictable over time to be able to look for anomalies relative to what that model predicted. So you don't have to create a rule in this case to protect that Java-based web application to say like, hey, this thing should never run Nmap or netcat. It should never listen on any port other than 443. It should only write to this particular file path, because you can learn that dynamically and you can create those rules automatically. So it's not just simply about saying, we're going to take this app and put it into containers and deployment's easier, maybe vulnerability management's easier. You can really have a much stronger ability to have active threat protection to the application or for the application, because you now can move to a model in which you know what is normal and you can automatically prevent everything that's abnormal. And that's a really key difference between this containerized kind of cloud native approach and what you could do with any traditional tooling that required sort of a manual configuration or the users to go in there and say what's good and what's not. So from a vulnerability management standpoint, the advantages that they've gotten from this move have been, they've moved from an approach in which vulnerability management was an inherently reactive technique. They would deploy the app and they would use Nessus or some other tool to scan it, and they would get a report of all the things that were bad, and they'd open up like some tickets, and they would never address the tickets, and then eventually like they do this whole thing again, a few months later. They've moved from that model into something where literally the security assessment is something that happens continuously. As they build the application, they're checking for vulnerabilities with every build. They can have enforcement at build time that, if this app includes Java vulnerabilities that are medium severity or higher for which a vendor fix is available, fail the build. Like, make the developer fix it right then and there, which reduces the risk, of course, but also reduces all of the complexity and hassle of trying to do that after the fact. They also have now a much clearer way to understand their vulnerabilities over time, because they don't have to be just continuously scanning the application interactively and incurring a performance penalty for that. They understand conclusively all the things that are inside of that container and can then look for anomalies or vulnerabilities without having to go out there and touch that container repeatedly and to scan everything on the file system, because they know everything that's inside of it because of that declarative capability that containers enable them to have. Compliance is another key feature. We talked about the fact that they have GDPR and FISMA and other requirements that they need to live up to. And historically, that was a completely manual process, as it is, in my experience, in virtually every Fortune 1000 type organization. If you want to do compliance, there is a human being, some person who has some kind of internal audit function who's going to have a checklist, and they're going to literally go through and look at all these configuration files, and there's going to be a spreadsheet, and they're going to put stuff in there, and they're going to follow through it, and it's a hideous manual waste of time, honestly. And it's so much better to do that through software, but historically it's been so hard to do that effectively through software, because the software baseline in a non-stateful or in a non-stateless environment, a stateful environment, is always changing, right? So you basically are always having to go out there and assess and figure out what's the current posture. With containers, again, because of that declarative nature, because they're predictable, you can not only check for that in production through automation very easily and say like, hey, is this container running as root? Is there a secret that's embedded inside this image? Does this container mount privileged ports? All, like literally hundreds of things that exist in, the CIS benchmarks for Docker and Kubernetes and so forth, as well as for like application things, can all be much more automated. But you can also have that same capability again throughout the lifecycle. So before the image ever leaves Jenkins, before it ever makes it into a registry, you can make sure that they don't have embedded private keys. You can make sure they have a named user for the application. Things that historically have been really difficult to enforce because they were all dependent upon a manual configuration can now be done much more kind of declaratively as part of your build process, because all of that declarative capabilities of containers enables you to wrap software around that to enforce the configuration throughout the lifecycle. And then finally is that capability around threat protection. I mentioned earlier that ability to be able to find and understand what is the normal behavior of an application. What are the typical processes that it runs? What are the sockets that it binds to? What are the outbound protocols it uses? The system calls that it makes? Like if you gave a person, a full day or multiple days of time to investigate that for just this one application, they probably would not be able to do that half as effectively as you can do with software, all right? With software, it's very easy to be able to say, we know this image, and this image, we can learn a bunch of stuff about the static configuration, we can kind of follow the entry point, and if there's a init script, we can learn about that, and we can, see what kind of static things might be declared in the configuration of the image. But then more importantly is once that image is running in a container, we can apply machine learning to learn about what is normal. Again, all the process activity, system calls, and so forth, develop what we call a model for that application that you can see and understand. You can actually grab that model out as a JSON object and share with a developer or archive for compliance purposes. But that model is something that can be generated purely through software. And if you think, from a traditional security standpoint, moving from an approach where you have to manually say everything that is, normal about your application, it's impractical to do that at any kind of even small scale in most organizations, because again, a lot of times the people that built the app don't even understand that, much less like a security team member that's coming in after the fact. And that's probably the most critical advantage that containers provide from a security perspective, is the ability to automatically learn what is normal about an application, to create a model that describes that normal state baseline across multiple dimensions, and to automatically look for anomalies relative to what the model predicts and prevent those anomalies proactively. You do not have to have a rule in this case that says, I should not be able to run nmap in this application. We know automatically that this app should only run a particular version of Apache, and anything else will just simply be prevented. And that's a really critical advantage that you can't really get unless you take this model of cloud native and containers and apply that software automation to it. So in summary, there's a lot of benefits from repackaging those monolithic applications into containers. Obviously, we talked about the agility, but also the security benefits, which was the core of this talk. And the thing I really want to highlight is that this is, while maybe not the most ideal end case, I'm not saying that you should look at this as preferable or even optional, frankly, if you have the opportunity to build an application to be truly cloud native. Clearly, if you have the resources and the time and so forth to build something from the ground up as a real cloud native app, there's a huge amount of advantage to doing so versus just simply repackaging it. The reality, though, in most organizations is there's going to be an enormous amount of legacy application base, hundreds of apps, and even fairly small, like Fortune 500 sort of organizations, hundreds or even thousands of workloads that you're never going to have the time or the money to rebuild from scratch. And this approach of containerizing those applications yields real performance and real security benefits in terms of how do you protect that application throughout its life cycle, and how do you protect it against active threats. And that's really one of probably the most important things that organizations can get from containers, even before they make the full leap to having everything in a cloud-native environment. So I'd be happy to take any questions at this point that you guys have. Yes? I'm sorry? What are the tools and the frameworks for the automatic analysis? I work at Twistlock, so I'll say our tool is the best tool for that. Also, some of the guys that wrote the tool up here in the front row, so if I didn't say that, it probably wouldn't go well for me. But I mean, I think just in general, like if you up-level that and say, like, don't talk about a particular vendor, the approach that you're really trying to take there is to have some kind of like observational window in which you say, like, let the app run, observe what that application is doing across multiple dimensions, and then describe that in a way that you can then use to have some kind of preventative engine later that says, hey, every process invocation, does it match what I have in the model? If not, stop it. You know, every network socket that's open, does it match what's in the model? If not, prevent that. And so the generic approach is really one about learning through direct observation, describing the declarative model for it, and then looking for anomalies relative to what that model predicts. Other questions? Yes?
How do you see OPA working into this container security environment, where you have these specific rules for what are you actually allowed to do in the application?
Yeah, I think tools are I guess technologies, I guess, like OPA. The opportunity there is to basically have the ability to call out to a security tool that can make decisions about what is good or not good and what should be allowed to run based on this analysis that you're doing. Maybe not like the runtime piece, which is kind of inherently like talking about things that have happened after you've deployed, right? But all that vulnerability and compliance piece is like a clear point of integration. It's certainly something, you know, we're looking at as well, which is to say like, you know, we've already built and have in our product, you know, our own mechanisms for preventing images from running based on, you know, vulnerability state and compliance state, and it's lots of granular rules. But there's a real opportunity now to make that a more generic approach that works across and works in a more integrated kind of pluggable way, you know, with the tooling that you're already using, but it can basically offload the logic and the decision making to a security tool that's going to implement the rules and use that learning to create the decision making framework that OPA would then actually enforce. Does that make sense?
So, truth be told, such an approach was possible for containers through mechanisms like SE limit audit logs, for example. How would you say those two things compare? Right?
Yeah, I'm definitely, the question is like there were previous approaches like looking at SE Linux audit logs that you could use to this. I'm not saying at all like this was fundamentally impossible to do before. What I'm saying it was fundamentally impractical to do it before, at least at scale, right? I mean, like the notion of like having a bunch of audit logs and then using that to convert some policy and then having software use that. Absolutely, you could have built things like that, and I think there have been companies that have done things of that nature. The reality is, though, it was really difficult to do that accurately before, and it was so manually intensive, no one was really going to invest in doing that at scale, right? I mean, like, the level of expertise that's required, you know, to go through that process, to understand it, to actually be able to create an output for it is so high that it was really just not something that most organizations could do. And I think, like, in general with containers, you know, one of the coolest parts of this whole space is that notion of, like, democratizing things that used to be, like, really high-end, like, you know, it was only available in Google, but now everybody can use it. I kind of think of this as a similar thing. Like, yeah, you could have done things like this before, but this is a way that everybody can do it in a really practical way. Like I said, even this organization is not an IT shop, it's an ancient application, but yet they can still get these advantages from just this transition. Yes? Yeah, the question is about the model and its life cycle over builds. I'll just answer this, and then I'll be outside for any other questions. The way that, at least that we do it, and there may be others that do it a different way, is as we build models, we correlate the models to the SHA of the image, basically. And so for every model, or every image build that you do, you're obviously going to have a new unique image, and so the model is correlated with that particular version of the app. And that's a really important thing because historically that's been hard to do, to try to figure out like how do you like reconcile different versioning and different configurations. In this case, we're basically saying each build is a unique image, each image is a unique model, and so you always have a model that's tuned specifically for that build of the application. And that's been, again, something that you really haven't been able to do at scale in the past because it just required too much effort. So I'll be outside for any other questions. Thank you guys for coming.